So I wanted to take some time to talk about clean code. I've never really been someone who cares about developer Twitter or Medium or articles like that, but I did recently read Casey Muratori's article here, Clean Code, Horrible Performance, and it was an interesting thing to look at. So if you haven't read the article, I highly recommend it. I'll link it in the description. Essentially, what Casey does here is he goes through some code that was written with solid principles and he subtracts all of the solid principles from the code and ends up with a much more performant program. And the point he's trying to make is that we've written code in such a way that we've outstripped the performance gains of better processors and more RAM and all that over time. So Casey did an interview with the Primogen, and something he mentioned in that interview was that in web, performance doesn't really matter, or at least it's not as much of a concern. So Casey works in games, and if you write a game that runs at 10 frames a second, no one will want to play your game, no matter how good it is. Whereas if you build a website that takes 3 or 4 seconds to load, but the content's interesting, or the product is something they need, people will stick around. And so I think we've ended up in this spot where we're in a vacuum. There's no direction for good code versus bad code. And so we've decided that clean code is the standard. And we gauge the level of a programmer or the quality of a piece of code by how well it adheres to clean coding principles. And so we've ended up in this spot where I think clean code is what you optimize for when good code is not a requirement. And so an example I'd like to give is my company's coding test. So the coding test goes something like this. We have a robot that has to clean a room. The room is represented by a 5x5 grid, and we're given a list of points that need to be reached and cleaned. The output of the program is a string in this format. So we have cardinal directions and C for clean. So immediately you're probably thinking, oh, this sounds like an interesting exercise. Maybe we could use Dijkstra's algorithm. We could, find the best path using that, drop some paths as we go along, maybe find a heuristic solution that would solve this problem. But there's one more line at the end of the coding test, and that is the optimality of your path is not considered for this test. So ultimately what we have is a traveling salesman problem where we're given a list of cities and asked to traverse them in the fastest order, except that we don't need to worry about the order. So our function would literally be parameter cities, return cities. So let's look at how this might be written by an average applicant in a sense. I've written this example, which I think is fairly representative of how most people solve the problem. This is Ruby, which I won't comment on. But we generally have a grid struct, we have a point struct, and then there's some sort of way of traversing this grid. So in our case, we have our traverse function, which creates a new point at 0, 0, starts an output string, and then walks to each of the points and appends the result to the output. So looking into how this code works a bit more, we have our walk to point function, which we're calling on each point, and then we're updating the current point to be the point we've just walked to. And our walk to point function is recursive. So we get the distance between where we are and the target point. If we are at the target point, as in the point is point.none, which up in our struct we can see is 0, 0, then we return C, the clean command. This is our point to character. We get our different, I suppose they're vectors, not points, but we return the character that represents that point. Then our direction is decided. If we are not at the point, we need to get the direction we need to go. So get next step with our distance between the 2 points. And our next step will say if the distance is y is greater than 0, we need to return north. If it's y is less than 0, we return south, and so on. Once we have our position decided, we return the character for that direction and the point to walk to. Sorry, this should actually be direction. I haven't run this code. And then we recursively walk to the new position. So this solves a problem. It models the problem, more importantly. That's a very OOP thing to do, is to model your problem so that the solution sort of falls out of the modeling. And it's fairly representative of what we would get as a code test. Now, in the interview afterwards, we might ask, oh, well, why did you choose not to create a vector class? Or why don't we have like a factory for the points? Or any number of other similar questions. And ultimately what we're asking is, do you know about this clean code thing? It's sort of the inside baseball concept of clean code, that if someone doesn't know all these principles, then they must not be a very good programmer. You know, certain design patterns can come in very handy, but a lot of them are just ways to gatekeep, essentially. So, what could this code look like? Let's go back to our problem. We're talking about an object operating inside of this grid. We're sort of treating it as a game. But we can't just treat it as simple maths. So given a list of points, we get the distance between each point, we add that up across each point, and then we convert that into a set of steps. We don't need to worry about the grid or actually moving across the points, we just need to decide the distance between each point. And so this could be represented as an algorithm more so than a game. And so the code we would end up with in that case is, we have our point struct again because we need to act on it as if it's a point. But we start at our current point, same as before. We have our output string. We loop through each point, and then we say if the get the x minus our current x, y minus our current y, and then we want to output east or west based on whether dx is greater than or less than 0, and dy, or north or south based on dy being greater than or less than 0. We multiply this by the absolute value to get a string of e's or a string of n's, and we're never going to have a situation where we go north and south in the same traversal because we're moving from one point to another. There's no point of going up then down. At the end of that we output our C and return our output. Now the problem is that if you wrote this code for a code test and it took you 15 minutes, you're probably going to think, oh, is there some trick that I'm not getting here? Is there some other better way to solve this problem? The answer is no. But what we will do is we'll expect you to have written it in this very complicated, abstracted way. At one point we had a candidate who said, I just find it easier to read when all the code's in front of me. Now, my coworker who was on the call nearly had an aneurysm, but he was making a good point. This is just an algorithmic piece of code that runs through some points and does something. This is an entire structure to understand. And I think if he was to phrase that better, it would be, I didn't want to add unnecessary indirection. We can see exactly what the code does right here. And to add more complication to it would just make it look more complicated. It wouldn't really do anything of value. Now, if we were to say, oh, maybe we have some more complicated cases, like we can move diagonally or whatever, this sort of thing might need to be abstracted. But it's only at that point that I would really consider it. And yet, we judge the quality of code by almost how complex it looks, rather than how simple it can be. And one thing you might not have noticed here, this code, even though it solves a problem, is much more computationally expensive because it's working it step by step as if it was a game. Whereas this one is just calculating each point directly. It's O of n. It has one loop. What's the complexity of this function? I don't know. It's doing all sorts of madness. It's doubly recursive, so probably n squared or some variation of that. But we can't easily tell. And so I've ended up seeing code like this and thinking, okay, no, this could be much simpler. And I generally bring up the point of performance. If we made this simpler, it would perform better. But I'm told that performance is a secondary concern. And what we're optimizing for is onboarding. So we want to have the most readable code. I don't think this is more readable. It might be more unit testable. But readability is ultimately in the eye of the beholder. We've conditioned ourselves to think this way. And if you haven't read the book Clean Code, or gone to a computer science course, this doesn't make a lot of sense. And so we've built less performant, less readable code. And performance is only a secondary concern until it isn't. So we've ended up in a spot where suddenly we need to query tens of thousands of records from our database. And it takes 30 seconds to do so, because of all the models and abstractions and service classes and decorators and all this stuff that lies on top of what is ultimately an SQL query. And yet somehow we're saying that this is better. The first app I wrote, nearly 15 years ago, looked something like this. It was a PHP app. This was a business directory for our local town, and I would list each of the businesses and their name, a description, and a phone number. This was actually, funny enough, embedded in a sort of Dreamweaver style site, and the category ID would be hard-coded. This was the entire app as far as logic went. The rest of it was just decoration. We connect to our database, we get our category ID from the get parameter, and we query all businesses that match that category ID. Then, for each row in that query, we return some HTML with the name, description, and phone number of that business. This code ran for 8 years with no changes. I didn't need to update my packages or load in new versions of a library or respond to CVEs or any of that stuff. Because the code is very simple. It has one parameter which is fixed, and it's escaped by PHP's prepared statements approach. So there's very little that goes into this program. And yet we end up with something that is simple and reliable. If you're in an interview and you end up with one of these interrogation sessions where they ask you why you didn't use X or Y principle, or, you know, should we have an abstract factory builder class that builds factories that build points that output grids, I'd be very conscious of whether you want that job or not. In the words of Fred Durst, sometimes some things become dumb things, and that's when you put your foot down. Don't work for places that enforce this upon you if it's not your style. If it is, enjoy it, because it's definitely not for me. Have a good one.